Okay, let's step it up with our inverse functions a little bit. Here we are simply using the proof of plugging in the inverse into the original function or vice versa, and hopefully it should equal x. So that's a fancy name for the property or whatever, but basically you plug one into the other both ways and it should give you x. So we're assuming that g of x is just the inverse of that. So we'll find out by plugging one into the other. So let's plug f of g of x. So anywhere we see an x in this function, we're going to plug in g of x, and it should give us x once we simplify it down. So we have 9 minus, and we'll plug in our g of x, so negative 10x plus 9, all that over 10. And let's see what happens. So we have 9. Let's distribute that minus sign in there. So we have plus 10x minus 9 over 10. So we see our 9 and minus 9 are redundant, so we have 10x over 10. And would you look at that, we have an x. So it works out that way. Let's try it the opposite way. So let's say g of f of x. So we have negative 10x, oops, except we're going to replace our x with our inverse function. 9 minus x over 10 plus 9. Let's see what we got. Well, we know one thing, once we throw that 10 in there, that those will go away, right? So we're left with negative 9 minus x plus 9. And that's a, oh, I'm sorry, we should have distributed the negative 10 in there and made that, oh, everyone makes mistakes. We have negative 9 plus x plus 9. And then those go away and give you x. So